let's jump right in. And so first up, we've got Hayleigh, who's going to be talking to us about if it's broke, fix it, programming language development in Elm. So please join me in welcoming Hayleigh. Thank you, Hayleigh.
Thank you. Cool, excellent. Yeah, so I just want to talk a little bit about programming language development in Elm, mostly because I think it's just kind of like a fun thing to do. I've been doing it kind of on and off for a couple of years now, like a little bit in Elm, some in JavaScript. I think I attempted one thing in Java once, which was awful, but you live and learn. Um, and also because I am currently working on a programming language called Ren, uh, and hopefully, maybe some of you, whoopsie daisy, some of you are interested enough to maybe come and take some work off my hand and contribute a bit to that. So, just before I go into a bit more, let me just talk a little bit about Ren, which is a functional programming language. It's kind of got all of the features you might expect, so pattern matching, enums or custom types as we know them, function composition, the pipe operator, and that sort of stuff. But it's dynamically typed, at least at the moment. So I expect maybe a lot of you are internally screaming like, why dynamically typed? Um, and I still really like JavaScript. It's like one of my favorite programming languages, which maybe is a slightly unpopular opinion in the Elm community. But I really enjoy writing JavaScript because it's kind of like quite creative or off the rails, I suppose. But I still really enjoy writing Elm, like especially for work or for more serious things. And I wanted a programming language that kind of took a lot of the things that I liked from Elm. So, basically those features I just listed out, pattern matching, custom types, that sort of thing. But then let me write kind of JavaScript or the dynamically typed Wild West stuff. And I want to show that off a bit today because usually when I tell people that I'm working on a programming language, um, quite a common reaction is people go, "Oh, wow, that's really cool," and then their next reaction is, "Oh, I wish I could do something like that," or like, oh, "I wouldn't even know where to start." Um, and I kind of want to try and maybe demystify that slightly. I don't think I'm doing really anything particularly clever or complicated with Ren, but I do have quite what I think is a nifty programming language that solves maybe some of my own needs, and it works, and you can run it. And hopefully, maybe a couple of you see that and think, well, like I think I could do that, and I want to throw together a little toy programming language to mess around with and have a bit of fun. So just before basically, I'm just going to walk through a few snippets from Ren's code base and just kind of show that it's not very like exciting or very complicated. But before I do that, this is just a screenshot from Ren's playground, just so that you can maybe get a bit of context for what the language looks like and what it produces. So on the left, we have some Ren code. This is for like 99 bottles of beer example, just like a kind of recursion thing. So we have like imports, which kind of look a bit like JavaScript and Elm imports smushed together. We've got function declarations and some local bindings. Pipe operator, which is kind of useless there, but mainly there for demonstration. And some very basic pattern matching, which could have easily just been an if expression, but I threw it in because I thought it looked cool. Ren's pattern matching does some fancy things. So we have guards, and you can do a bit more than just matching of values, but that's maybe beside the point. And then on the right, we have the JavaScript that spits out, which I think is quite readable. It's quite human readable, I guess. It's not a big garbage. And that really comes just from this expression type. I mean, there are obviously declarations and modules and stuff, but it really boils down to what I think is a fairly self-explanatory type here. So for example, we have this access variant, which is for like object access or array access. So you have like an expression, which might be just an identifier or an array literal or a function expression or something. And then like a chain of accessors, so like dot accessors if it was an object, or like square brackets if it's an array. We have things like conditionals, which is just if this expression, then this, else this. Yeah, and I think this is quite simple, right? I mean, we have some other types. So we have like this pattern type and an identifier and literals. But at the base of it, I think it's quite simple. So the first thing that we need to think about is basically how do we parse some source code into this. And so for that, I'm using the Elm parser library. So this is a chunk of the block parser. So a block is an expression wrapped in curly braces, and then you have 0 or more declarations. So that's like this make verses or this verses. These are declarations. And then a return keyword. And then we kind of recurse on the expression parser itself to parse the main expression or the body expression. And I've left out some kind of white space handling, but really this is all there is to the block parser. And the way I kind of approach these things is I just take every variant of the type and just write a very literal parser just for that variant. And then you can piece them together. And for that, I'm using this package for Pratt parsing, which is a type of parsing that basically lets you do operator precedence. So, if you have binary operators or something, you can bind them either closer to the left or the right so that you have proper operator precedence. And so we start off with one of our kind of top level parsers. So in this case, that block parser I just showed, and then one of, so like a pipe or any of our operators really. And then we just say, these are separated by some ignorable characters. And that's really all there is to parsing Wren code into this AST that we have in Elm. And so there's kind of a lot of boilerplate, and there's quite a lot of bugs that you have to work through when you're throwing these parsers together. But they're not magic, and they're not particularly kind of complicated Elm code. Like whenever I tell people about Wren, and they're like, "Oh, can I have a look around the code?" I'm like, "Oh, you can." But most of it isn't very exciting. Like you're not going to think I'm very clever for me writing some fairly simple parsers and just piecing them together into these kind of bigger chunks. And then the next thing that Wren does is we transform that AST. At the moment, that is basically just applying some constant folding, which is like compile time evaluation of some expressions. So like we can optimize away if you try and add two number literals, we can just replace that with the result at compile time, which I think is quite nifty. And we're using this transform package for that, which lets you recurse over like a tree or like a recursive data structure. So this is, I mean, the definition for constant fold is quite big. I think it's like 500 lines long, just because you have to handle quite a few different cases in the AST. But the actual logic itself is, again, really simple. Maybe I can just throw this up quickly so you can see. Nope. So, for example, when you add two numbers together somewhere around here, Well, this is handling the case where you add, say, a number on the left side and some other literal on the right-hand side. We can do some coercion to work out what the value would be, kind of like the horrible thing you would do in JavaScript if you wanted to add a number and a string together. We can do that at compile time, which I think is quite cool. But I mean, this isn't particularly mind-blowing in terms of complexity, right? This is just kind of converting, say, our string literal to a number. There's nothing really mind-blowing going on here. So like we can add two strings together and we do that at compile time. And a lot of the complexity is just handled by the packages that we use. And then finally, we have to spit out some JavaScript, right? And the very first pass that I did of that was just basically I had a JavaScript string and then I just replaced it, right? And then kind of in the same way that I work from the parser, you just have functions that take like the smallest parts of an expression and turn that into a string. And then you just build that up into kind of a whole function declaration. And that was working for a while, but I mean, it's kind of not very good to do that if you want your compiler to be taken seriously. So I moved on to this pretty printer library, which, I mean, it doesn't look as immediately self-explanatory, but really this is kind of working like a parser, but in reverse. So where you might write a parser and say like parser keyword function and then parse a pattern and then a space. This is doing the same thing just in reverse, and then that spits out quite nicely formatted code. One nice thing about that package is it lets you do word wrapping, which I haven't really worked out yet, but I'm sure I'll get to it soon so that you don't have to scroll for miles on end. But again, this is all just kind of busy work, right? This is all just kind of boilerplate. And from just sort of this AST, this quite simple expression language, and a bit of time in throwing all these pieces together, I've managed to come up, with quite a cool programming language that you can run. By the way, this playground is written in Elm as well, which I think is quite nifty. So you can like evaluate the code. There's a little console output there. And that's really all there is to it. I mean, you can obviously get quite deep into this, especially if you start diving into type theory and static typing. But just for a toy language, maybe for something, I don't know, you just want to hack something together, you've got like an idea for like a small app or just a simple script, and you don't want to use JavaScript or Python or whatever, you can actually quite quickly throw together kind of like your dream scripting language or thereabouts in relatively little effort and just quite a bit of boilerplate. So if you wanted to learn maybe a bit more about how you can do this in Elm, you can go peek at Ren's compiler. There's the Elm in Elm project, which I stole a lot of ideas from. The compiler is organized in pretty much the same way. There's Stable, which is maybe I would say kind of the most complex example of a programming language done in Elm at the moment. There's the Awesome list if you want to go check that out and see some other projects, including a few kind of Lisp evaluators, and see some of the other packages that you can use to help you through this. And then there's this channel on the Elm Slack that you can drop into and ask me or a couple of other of us some questions. And that's pretty much it from me. I didn't really have much planned. I just thought it'd be kind of cool if a few people were maybe inspired or interested in this sort of stuff. I noticed that over maybe the last year or so, there's a few people doing programming language things in Elm, but kind of all in their own little silos and not really communicating with each other. So I thought it would be a good opportunity to maybe shed some light on that and bring a few people together. So thank you.
Awesome. Please join me in thanking Hayleigh. Thank you, Hayleigh. Okay, so open floor for any questions.
I was just curious with something I think you showed us that there's like a lot of these little optimizations that can be done, right? And there's like this very big case expression with all the optimizations that can be done. Do you think that would be slow, like on a real language, or do you think that that's not really a problem?
Well, this sort of, it's called constant folding. It's quite common in languages that have that optimization, right? No, it's not really the slow part. I wouldn't say the slow part is usually like the file I/O and the type checking and solving constraints and that sort of thing. This wouldn't really be the bottleneck, I wouldn't say. And there's probably some cleverer ways to do it than I'm doing as well, if you really wanted to eke some performance out of it.
I have a question on the topic of performance. Like, how many lines per second does your compiler handle?
That's an excellent question, and I have no idea.
Okay, I guess it's hard when there's like the examples are 100 lines. Like,
yeah. I mean,
blink and you'll miss it.
I tend not to care about performance until it becomes a problem, and then I solve it. So the language itself is still kind of in flux in terms of features or implementation, so I'm not really worrying too much. Actually, I mean, I don't actually have a CLI yet, so you can't even compile files. It's purely the playground, and the compiler is published as a package, but there's no file I/O, so I couldn't even begin to tell you.
Cool, thank you.
Maybe I have a question. I mean, developing this kind of language, I've also done some kind of toy languages myself. I mean, did you come across this point where you sometimes discover that one of your early assumptions was maybe wrong? And I mean, how have you approached that problem? Like, did you fix it, or did you like kind of accept that you went down this route? Or
yeah, I mean, again, Ren is still kind of pretty early doors, so I'm quite happy to kind of throw my hands up and be like, oh, well, that was the wrong approach, or that didn't work, and then just kind of scrap everything and start again. I can't think of any examples off the top of my head that were really kind of big showstoppers or kind of, wow, that really wasn't the right approach yet. Mainly because I've been avoiding making decisions on those sorts of things for the time being. I think the big one that I need to kind of hunker down and hash out is kind of setting up the infrastructure for like good compiler errors and parser errors and that sort of thing, and making sure that there's quite a nice pipeline for handling those sorts of things. At the moment, there's like no error at all. If you just type bad code into the playground, it just doesn't spit anything out, and that's it. You got to work it out. But yeah, I think those things will come up. I don't really have any examples at the moment.
Okay, I might jump in with one. You were showing us some of that implementation stuff on a file that was called optimize. So am I right that in assuming that at compile time, you're basically simplifying the AST down as much as you can and then outputting JavaScript?
Yeah, that's exactly it. I plan on doing things like, there needs to be like a desugaring pass that I don't do at the moment. But yeah, I kind of have it structured so that you just kind of go through these passes before you. I mean, you could spit out the unoptimized JavaScript. So the way the package is organized is like all of the individual stages are also exposed to you, so you can skip optimization if you wanted to. But by default, yeah, it optimizes as much as it can.
Cool. So a second question there would be then, do the semantics of Ren require it to be executed finally in JavaScript, or could you skip the JavaScript output stage and have an interpreter for the AST?
Yeah, I think I could write. Well, I mean, I definitely could write an interpreter, and I was playing around with the idea of maybe doing that, just so you could have like kind of a small embedded scripting language for Elm things. But then I couldn't really think of a reason why you'd want that, and I benched the idea. But the semantics themselves aren't really anything special. So yeah, you could absolutely write an interpreter for it. It would mostly just be like standard library things, like implementing strings and arrays, like in the language itself. You'd have to work that out if you were going to do that in an interpreter. But it kind of leans quite heavily on assuming that you're running JavaScript, but there's not really any reason why it couldn't emit like Python or something and still work just fine.
Cool, great. Okay, any other questions for Hayleigh? Okay, join me again in thanking Hayleigh for her talk. Thank you, Hayleigh.
Thank you.